Dear students, welcome you all to the course that is Fabric Manufacturing Technology. So in the previous sessions, the unit 1 and 2, we have discussed about complete weaving preparatory process. So once again I am repeating that what is we have learned from the unit 1 and unit 2 are unit 1 we have discussed about winding technology. So how the yarn package, that is a smaller package to the bigger packages, are going to be converted, and along with that one of the major objective in the winding is the clearing of yarn faults. So the conversion of smaller package to the bigger package and the clearing of objectionable faults from the yarn coming from the ring spinning. So that is called as like a winding, and we have discussed in the second half unit of unit 1, we have discussed about the warping technology, how these single yarns are going to be converted into a sheet of warp for the weaving process. Okay, so warping, we have discussed again in the warping what are the different types of warping machines are there, like direct warping or beam warping, and the second one is called as the sectional warping or called as indirect warping. So we have discussed in these two machines what are the different zones and what are the different parts which are involved in the manufacturing or production of the warpers beams as well as the weavers beam. So once again I am reminding you that in the warping, that is particularly in the beam warping, we are going to produce warpers beam, and in case of sectional warping machine we are going to produce weavers beam. Okay, so these warpers beams whatever we have produced by the direct warping machine, we are going to keep these beams, several beams together in the sizing creel, where the individual beams or several beams are going to be converted into a one beam, that is weavers beam. So in the sizing process, that too particularly we have discussed in the unit number 2, what are the objectives of sizing, what are the different ingredients we are using for the preparation of size paste. Okay, what are their functions, as well as what are the examples of size ingredients, that is particularly like a primary size ingredients and the secondary size ingredients. After the selection of the size ingredients, particularly for the different types of yarns, specific yarn type, that is 100% cotton or PC blends or blended yarns, or so completely like a polyester. So how we can, and what are the parameters to be considered while selecting the size ingredients, we have discussed. So along with that we have seen that the particularly size application, that is sizing machines like a 2-cylinder sizing machine as well as multi-cylinder sizing machines, and various zones in the sizing machine also we have discussed, and their individual importance also we have discussed in the unit number 2. So in the sizing process, so we are going to apply the size ingredients into the yarn so that the yarn becomes weavable in the further process, that is it will going to sustain whatever the stress and strains which are going to be produced or applied in the weaving process. Okay, so that is why we are using the sizing to the yarn so that the yarn becomes more strengthy, so that it can be resisted whatever the forces which are applied in the weaving process. So after sizing, these weavers beams are going to be transferred into the post sizing operations. So the last topic in the second unit we have discussed what are the post sizing operations. The post sizing operations are drawing in and denting, or sometimes we are going for the knotting. So drawing in and denting, we are going to do these operations for the new qualities or new style of the fabric. So if the new quality of the fabric, quality in terms of like so the weave, the yarn count, the color patterns, all these together we are going to call it as quality. Okay, so quality different. For example, the new quality is came, we need to produce the new quality. In that case, we are going to select the drawing in and denting process. Okay, so if, for example, if the same fabric we need to produce for long runs, for example 1 lakh meters of fabric we required, so in that case 1 lakh meters of warp we cannot accommodate in one beam, so we are going to produce several beams in the warping machine, then the sizing will be done. So whenever, if the quality of warp or if the quality of fabric produced in the weaving process is same, in that case what we are going to do is we are going to select the knotting process in the post sizing operations. After sizing, this beam is directly sent to the weaving area wherever and whenever the beam is exhausted in the weaving process or in the weaving machine. In that time, after exhaustion, at the end of the exhaustion of the warp beam in the weaving machine or the completion of warp beam in the weaving machine, we are going to take this new weaver's beam into the weaving area and we are knotting the new warp ends into the running ends in the weaving machine. Okay, so this is called as the knotting process. So why? Because we are going for the knotting process, because we are going for the knotting process if the quality is same, so there is no need to go for the again drawing in and denting. So as I told, drawing in and denting, it will take more time consuming and we are going to so like more time consuming, nothing but, for example, it is going to be depends upon number of ends. For example, if the beam is consisting of 10,000 number of ends, so this 10,000 number of ends to draw through the drop wires and heel wires and then the reed ends, so it is going to take approximately 8 to 10 hours of time. Okay, so if the number of colors are different, again it will take more time. Okay, so that is why what we are doing is, if the yarn quality or if the fabric quality is same, in that case we are going for the knotting operation. So we can eliminate the time consumption for the drawing in and denting process. So approximately the knotting machines, as I told in the earlier classes, so the knotting machine can knot the ends 500 to 600 ends per 1 minute. So 500 ends per 1 minute means if the beam is consisting of 10,000 number of ends, approximately it is going to take hardly 20 minutes of time for the knotting of all 10,000 number of ends in the weaving machine. So total so complete process of knotting, it will hardly take 1 hour, like arrangement of warp ends and knotting, then drawing the knots through the heel wires and reed ends. So approximately it is going to take only 1 hour of time. So but in case of drawing in and denting process, it is going to take 10 hours of time. So now we are reduced 9 hours of time. So we have saved 9 hours of time as well as the wages of the workers. Okay, so we'll get the industry will get the benefit out of this. Okay, so that the industry will get profits of that. Okay, so these are the things we have discussed in the unit 1 as well as the unit 2. Now after the post sizing operations, like for example, if we have done drawing in and denting operation, so this drawn beam is going to be transferred with the help of material transportation equipments, okay, like a beam transportation equipment. So by using that, we are going to transfer from the post sizing operations, that is from the drawing in and denting area to the weaving area. Okay, so now in the unit 3 we are going to discuss about what is exactly the weaving process is. Okay, what is exactly the weaving process. Okay, and once again I am reminding you that we are discussing out of the total fabric manufacturing processes, we are discussing woven fabric manufacturing process. Woven fabric manufacturing process. Okay, so we'll discuss in the unit 3, that is particularly shuttle weaving technology. Shuttle weaving technology. So what are the topics we are going to discuss in the unit 3 is, you can see here. So the introduction to what weaving, what is exactly the weaving is. Okay, what is weaving? Okay, and what are the different types of loom motions are there. Okay, and how these loom motions are classified. Okay, that is like classification of loom motions. Then after that, so each and every classification of loom motion, like a primary motions, secondary motions, auxiliary motions, we have 3 different types of motions. So these 3 different types of motions we are going to discuss in the unit number 3. So you can see that there are shedding mechanisms. What are the different types of sheds? What is picking? How the weft yarn is inserted? What are the mechanisms involved? After insertion of the weft yarn, how this newly inserted weft yarn is going to beaten towards the fell of the cloth. Okay, and what are the mechanisms involved to release the warp yarn from the warp beam, and after making the cloth, how the cloth is going to wind with the help of take-off mechanism. Okay, for example, if something is happened in the weaving loom, or the warp threads are broke, or the weft yarns are exhausted, in that case automatically how we can stop the loom. Okay, so that are auxiliary mechanisms. Okay, so we are going to discuss all the things, particularly in the shuttle looms. What are the mechanisms? Like all three motions or mechanisms, like primary mechanisms, secondary and auxiliary mechanism. So we are going to discuss particularly in detail in this particular unit number 3. So this session, specific to this session, we are going to discuss about what is the introduction to the weaving process. What is the introduction to the weaving process? And we are going to discuss about what are the classification of loom motions. What is exactly the loom? What are the loom motions are? Okay, and in specific to that, out of these 3 loom motions, we are going to discuss here particularly in the primary motions. We are going to discuss about the shedding mechanisms in the shuttle looms. Okay, so these 3 topics we will discuss in this particular session. We will look after the first title, that is first topic, that is introduction to the weaving. Okay, so what is exactly the weaving process? What is a weaving process is? So as I mentioned earlier, the weaving process is nothing but the production of fabric by interlacing warp and weft threads. So simple, the process of producing a fabric by interlacing warp and weft threads is known as weaving process. Nothing but interlacement of warp and the weft threads. Okay, so interlacement of warp and weft threads is known as weaving process. So the machine which is used for the weaving, which is used for the weaving, so weaving nothing but interlacement of warp and weft. So what is the machine we are using? The machine which is used for the weaving process is known as weaving machine, or we can say that the loom. The loom. Okay, so the machine which is used for the weaving process is known as weaving machine or a loom. Okay, so weaving is an art that has been practiced for thousands of years. Okay, so weaving is an art. So as of today, there is a wide range of looms being used. Previously, like in the conventional manner, like there are hand operated looms, that is hand looms are there, and a little bit development has been taken place by the inspiration of these hand looms into the power looms, so that the production capacity, nothing but the fabric production capacity, is going to be increased by using the plain power looms as compared with the hand looms. Because in the hand looms the man requirement is must and should, and man can work particularly the specific speed and the specific time. Okay, so the energy, by considering all the factors in the hand looms, now there is a small modifications which is a motorized things are developed in the loom. So the plain power looms has been came into the picture to get the production to get the more production as compared to the hand looms. So the power looms are going to be produced somehow more production than the hand looms. So after the power looms, again there are so many drawbacks, and there are limitations in the production ranges and the quality ranges, particularly the weave of the fabric and the structure of the fabric. Okay, if you want to produce small motifs or complicated designs in the fabric structure itself, so it is somewhat difficult. So that is why after these plain power looms, nowadays there are wide range of shuttle-less looms came into the picture. So we are going to get the production 4 to 6 times more than the plain power looms. For example, simple example, a hand loom is there. So a hand loom, for example, hardly is able to produce, for example, if he is efficient, he can able to produce 3 meters of the fabric or 5 meters of the fabric per day. So per 8 hours or 10 hours. Now these plain power looms, you can work at the speed of 200 picks per minute. So hardly you can get approximately, so you will get 10 meters to 20 meters or 30 meters of the fabric. So maximum, that is 30 meters of the fabric, that is depends upon the picks per inch and few working parameters. So now we have shuttle-less looms, so where you can get the fabric per shift of 70 meters per shift or 100 meters per shift also you will get. Okay, so even in the case of air jet looms, you will get 3 times more than that. Okay, so the production range and the quality range is also going to be very, very different. More number of qualities can be produced in case of shuttle-less looms. So nowadays there are shuttle-less looms also. So particularly in the present, our third unit, we are going to discuss about the shuttle looms. And shuttle-less looms are going to be discussed in the unit number 4 and 5. Okay, so now in the plain power looms or in the shuttle looms, what are the basic mechanisms which are there in a plain power loom is. And once again I am telling, these basic mechanisms are common for all the looms. So even for the hand looms and plain power looms and the shuttle-less looms, so whatever the category in loom, what are the motions or what are the mechanisms? These mechanisms are so must and should, but the mechanism which is used in the particular case is different. Okay, these motions or mechanisms are must and should, but by means of manual mechanisms are there, and there are automatic mechanisms are incorporated in the shuttle-less looms. So this is the difference. Okay, and in order to interlace warp and weft threads to produce the fabric, so the following mechanisms are very, very necessary. So there are some mechanisms are required to produce the fabric, to interlace the warp and weft threads. So those are primary mechanisms and secondary mechanisms, and third category, that is auxiliary mechanisms. Okay, so primary category, again there are classification. Secondary mechanisms, again classification is there. Auxiliary mechanisms also there are. So there are many mechanisms are involved in the particular category. So basically the mechanisms or basic mechanisms in a loom is one is primary, secondary and auxiliary mechanisms. So once again I am repeating: primary mechanisms, secondary mechanisms and auxiliary mechanisms. Okay, so these three mechanisms are very important. Now we will look after what is in each and every category. We have the classification, sub-classification. Okay, you can see that the classification chart, how these loom motions are classified. So the loom motions are classified into three categories. One is called as the primary motions, then second one is called as the secondary motions, and tertiary, or you can say this is auxiliary motions. Tertiary or auxiliary motions. So we will see that what is in the each and every category or each and every classification of these motions are. So you can see that primary motions again classified into three basic things. So primary motions are classified into three basic motions. One is called as shedding, second one is called as picking, third one is called as beat up. Shedding, picking and beat up. You can see that number one, shedding, picking, beat up. So this order is same. You should not change the order. First shed opening will be done. Then there is a weft insertion will be done. After weft insertion, the newly inserted weft yarn is going to beat towards the well of the cloth. So whatever the order I have given is, the order is, you have to remember the order. You should not change that. The beat up will be done first, second shedding, third picking. You cannot. So this shedding, picking, beat up is the primary motions. Shedding, picking and beat up are the primary motions. Okay. And again in the shedding also there are so many types of shedding mechanisms and picking mechanisms. Many types are there. So that we will discuss in the further sessions. So primary motions, basically it was classified into three, that is shedding, picking and beat up. And you can see that the secondary motions. So secondary motions are two, only two. One is fabric take up and second one is warp let off. Warp let off and fabric take up. Warp let off means warp beam. There is a warp beam, that is weaver's beam, which is going to be available in the weaving machine. So the warp beam we can call it is warp beam. So how this warp is going to be released? Warp it is released, then only we can able to form the shed and we can able to weave the cloth, right? So how the warp is releasing? After fabric making, the fabric how it is going to wind up into the cloth roller. So warp let off, fabric take up. Fabric is taking up, warp is letting off. Okay, warp is delivering to the weaving zone and fabric is going to take up to the cloth winding mechanism. So these two are the secondary motions. One is called as warp let off, second one is called as fabric take up. Fabric take up. And you can see that the tertiary motions and or auxiliary motions. Tertiary or auxiliary mechanisms are like warp stop motions, like nothing but if the warp yarn is broke. So we need to stop the loom. Without the particular end, then what will happen if the yarn is not there at particular place? So there is a appearance, the bad appearance of the fabric will be there. Like nothing but you can see that visually, like there is no warp thread, there is a miss end. Okay, so whenever the warp yarn is break, at the time we need to stop the loom. So there is a mechanism, whenever the warp thread is break, the mechanism will stop the loom. Okay, so that the weaver or the man who is working in the weaving area can go and attend the warp break. So similarly, like weft stop motion also there. So weft is exhausted. In that case, we need to stop the loop. And there are reed stop motions also. Okay. So for example, if whenever the picking is happening, So if the shuttle we are using to transfer the weft yarn, right, you can observe that at my back side there is a shuttle which is inserting in the loom. So whenever this shuttle is inserting automatically or by using the mechanism, so in that case, for example, the force required to transfer from one side to other side is not sufficient. In that case, what is happening is the shuttle is going to be trapped inside the warp threads. So now you have to stop the loom whenever the shuttle is trapped inside the warp threads. Okay, so that is why there is a reed stop motions, and there are temple motions also there. So temples are used to maintain the fabric width or maintain the fabric tension in the width direction, and there are like weft package replacements also, automatic weft replenishment or replacement. So automatically there are like small mechanisms which are going to available in the weaving machine, wherever like in the shuttle we are using a small amount of purn, right, the yarn quantity is smaller amount, right. So whenever the weft yarn is exhausted in the shuttle, so automatically the shuttle is the particularly like in the shuttle we have a weft package, the weft package is going to replace with the help of some mechanism. So whatever these mechanisms are, like these are auxiliary mechanisms, it is may be required, may not be required, but in case of automatic looms, but in case of shuttle-less looms, these auxiliary mechanisms are very, very important to get more production, okay, to reduce the idle time. For example, if you have a hand loom, so these whatever the auxiliary motions are there is no auxiliary motions. So if the warp thread is break, the man who is doing the fabric formation is going to identify the warp threads, and he is going to observe every time, every peak time he is going to observe, and whenever the warp thread is break, he has to stop by himself only. Okay, so there is no mechanisms. If the weft yarn is exhausted, he is going to see every time in every peak, so he is observing that there is a weft package or weft yarn present in the shuttle or not. Okay, so manual process, it is a completely manual process. So sometimes it may be like mishandling or manual errors can be occur. So in case of automatic looms, it is very, very important to get higher production, and the quality can be maintained by using these auxiliary motions. Okay, so these are the complete classification of these loom motions or loom mechanisms. So once again I am repeating that the loom motions are classified into three categories. One is called as primary motions, secondary motions, and tertiary or auxiliary motions. So primary motions are classified into three categories, that is shedding, picking, beat up. Shedding, picking, beat up. And secondary motions are warp, let off, fabric, take up. And auxiliary motions are warp stop motions, weft stop motions. Okay, so warp stop motion, weft stop motions, and we have temples and reed stop motions or weft replacement or replenishment motions. Okay, all these are comes under the category of auxiliary motion. Okay, these are the loom motions which are basically there in case of shuttle looms as well as the shuttle-less looms. So any loom, these motions are very, very important to get the production as well as to get the good quality of the fabric. In a simple video, we will see that what are the primary motions and secondary motions in plain power looms.
Shedding means separation.
So let us look out
weaving,
the primary motions and secondary motions
with
in
some forming the lower shed and others forming the upper shed. This separation is made possible by the up and down movement of the harness frames. The second motion needed is filling insertion. Through the open shed of warp yarns, the filling yarn is inserted so that it interlaces with the warp yarns to produce a particular weave design. Beat up is the third motion that the weaving machine performs. It is done with the aid of a reed as it moves forward, beating the filling yarn into the fabric. As these first three weaving motions are taking place in a timed sequence, the warp yarns are simultaneously let off or unwound, the fourth motion, as the produced fabric passes to a take-up system, the fifth motion, to form a cloth roll. These motions are required on all weaving machines, whether they are hand looms or automatic looms.
So in the next session we will discuss about one by one, that is primary motions and secondary motions and tertiary motions. Okay, so till then, thanks for listening. Bye.